Hello everyone, welcome to my programming club. Today we will be solving another daily code challenge, and the challenge name is letter combinations of a phone number. So given a string containing digits between 2 to 9 inclusive, you have to return all the possible letter combinations that number could represent. Return the answer in any order. So the mapping of digit of letters is given to you. So what the proof statement is saying is, let's take an example, make you understand what we are required to do this in the program, required to do in the program. Uh, Let me quickly copy it. Yeah. So let me quickly copy the mapping also. The mapping is giving a little trouble to proper. Anyhow, uh, we can just have a look. Or I have also made the mapping in the code also. That would be fine if we just copy that instead of copying that image. Yeah, this is the mapping given to you. And what was the input? 2, 3. So 2, comma 3 was the input. 2, 3. This is the string input you have been given. You have to return all the letter combinations that these digit combinations can form. What you will be doing is, these are the digits that are corresponding to the numbers that you will be given in the input digits, input string, or which is named digits. So you have to return letter combinations. Letter combination that number could represent. Letter combinations. All the letter combinations. So let's say first digit was 2. It is essentially a phone. If you are familiar with the keypad phones or the feature phones that were early that came earlier to the touchscreen ones, uh, in those phones there were keys, and each key was having a digit and alphabets. Each key from 2 to 9 was having a digit and a list of alphabets, or say letters, which it can which can be mapped to that digit. So here, for digit 2, these letters are mapped to 2. When you press 2, you can have one of them. If you can all have A, you can have B, you can have C, and depending upon your selection, again there will be choices. Now the next digit is 3. Let me quickly change the color. Next digit is 3, and 3 is having again 3 choices. It is D, E, and F. Let's say you decide to go this path, and then you decide to go this path. After the length of the combination is equal to the length of the digits, let's say length of the digits is equal to the length of the letter combination, then we will terminate our search for the combination and our combination will be formed. So depending upon your choices, various branches will be branching out of this decision tree or say recursion tree. Decision tree. Decision tree is nothing but the representation of your choices in a graphical way. It's a made up construct. It's not actually a tree. So depending upon your decisions, various branching will be branching out, and you will explore a branch till the very end. When it will hit the end, when the length of the digits will be equal to the length of the letter current combination formed. So as soon as we reach the end, what we will do is we will come back and then we will explore another option. Let's say we explore B. Then for B also, we will when we will hit the limit, which is the length of the digit will be equal to the length of the current letter combination, we will again come back. Then we will explore C, another option, which is C. So this uh, checking of current branch till end and then coming back to explore other branches called backtracking. Those of you who are not familiar with what backtracking is, I will provide a link for an article describing backtracking. Link. So, and when we are traversing a branch till the very end, it is called depth first search. We are first exploring the depths of a single branch. First exploring depth of a single branch before exploring other branches. This technique of searching or exploring is called depth first search, DFS. Those who are new with depth first search, I will provide a link for an article describing depth first search. Then you can have a clear understanding what we are doing here. So this is nothing. This whole process is nothing but depth first search plus backtracking. So you are exploring the depth, and then you are coming back to explore another branches. And as you are coming back, let's say you have a bag. In that bag, you are sequentially storing your choices. First, you take the choice of A, and then you take the choice of E. Now, at the end of the branch, you are having these numbers, these letters in the bag in this order. So, your combination will be AE. Now, when you will be coming back from the end of the branch, you will be coming back. What you will do is you will one by one you will be one by one removing them in the order in which they were opposite to the order in which they were enqueued. So first the last enqueued one will be removed, E will be removed, then A will be removed, and then your bag will become empty, and then you will be exploring this option B. Then depending upon your second choice, you will have a bag of 2 letters at the end of the branch, and you will be doing the same process again and again. So this is the backtracking part where you are you are resetting state of your bag. The bag is a hypothetical construct that I have made up so that you have to you could understand how we are storing the current choices of letters while exploring a single branch, and how we are using that container in which we are storing the choices of the letters again and again while exploring another branches. So I hope it's clear to you. If it's not still not clear to you, it will be clear to you in the coding part. And also, I forgot to mention that the constraints here are pretty much low, so you need not have to worry about them. Let's quickly have a discussion of the constraints and the time complexity. So here at max you can have as you can see, at max you can have 4 choices for each character, for each digit in the digits string. So there will be at max 4 choices, and how many number of digits will be there in the digit string? It is given to you. It is nothing but 4. So 4 digits and each having 4 choices will be 4 raised to power 4, which is lesser than 10 raised to power 8 operations allowed in 1 second. Those of you who are not familiar with how the time complexity of accepted solution varies according to input size, I'll provide a link of an article describing this so that you will be able to understand it, what we are doing here. As of now, what I can tell is in 1 second you are only allowed 10 raised to power 8 operations, and if your program is doing lesser number of operations than this figure, then your solution will get accepted. If it's equal to or greater than this number of operations, then your program may generate a time limit exceeded error. So you may get a TLE. If it's lesser, then your solution will be accepted. Now 4 raised to power 4, it's pretty much less than this 10 raised to power 8 operations. So you need not have to worry about that. Also, the space complexity wise, uh, what will be the depth of a single branch? What will be the maximum depth? It will be nothing but the maximum length of digits string. So what is the maximum length of the digit string given? It is given to be 4. How we will be using force this much space, because we are exploring each branch one by one. When you are done with exploring this branch, let's say this will be popped out of the recursion stack. Popped out of the recursion stack. And this space will be reclaimed and this space will be used again. So at most O of n space will be used, and yeah, that's pretty much it. And what will be the time complexity here? Time complexity will be n raised to power 4, since 4 is the maximum number of letters associated with the digit, and here is also 4. So this will be the time complexity and this will be the space complexity. So these are pretty much low, and so you need not have to worry about them. So let's move to the coding part. So what we have done here is we have just created a map of numbers in the digits string with their corresponding letter choices that we are having. This is for 2, this is for 3, this is for 5. Sorry, this is for 4. Which is nothing but this mapping that I have drawn here. This is the mapping that I have taken from the code. So since it will be a zero-based indexing, you may ask how we will be adjusting the values. So for from each of the values of the digits, we will subtracting 2. So the relative difference between 2 and 2 will be 0. So it will be at the 0th index. Now let's say the digit given to is 6. Now the relative difference between the 6 and the 2 is 4. So it will be given at the 4th index, which will be 1, 2, 3, and 4. So this will be the way how we will be able to accommodate these numbers mapping in the zero indexed array. So or say vector. So this is what we have done. Uh, Now we will return the result containing the all the letter combinations in string format, and this is the current character sequence that we'll be exploring. This is to store the choices of current branch of DFS, current branch of decision or say recursion tree being explored in DFS. This is nothing but the hypothetical construct that was named bag that I have shown you here. This bag, sorry if the spelling is incorrect. This bag, this is nothing but the bag. So this is the bag that you will be storing your combination in current combination. So this is nothing but a depth first search. This is nothing but a depth first search for the combinations. But what are the combinations? The letter combinations. So this is the DFS approach. This one. So this is a mapping of numbers and digits, letters and digits, mapping of letters and digits. So what we are doing for each digit under consideration, let's say you are at currently like the input given is 2. So what will the relative difference between 2 and 2? It will be 0. So we will go to the 0th index. It will be the letters options for current digit which is 2. As you can see in the this clip or this photo also. Uh, so this will how we will accommodate. Pardon me if some spelling is incorrect. I hope it does not affect your learning. Uh, the mappings in a 0 based index vector or say array. So we are checking the relative difference, and according to that we are generating the index. in the map. So these are the options for the current digit. Options of letters for the current digit in digits string. So you will explore all the options in a depth-wise manner. Explore all the options in a depth-wise manner. So this is your this character string is nothing. Character sequence is nothing but a hypothetical construct that we were calling back. So this is you think the current choices in the bag. So and this is you emptying the bag so that you can explore other ways of the recursion tree. So that's pretty much it. This was the one approach. Now we will be also discussing another approach for this. This was the DFS approach. We have discussed the DFS approach. Now, if you observe, we can also in this approach we were going in a depth-wise manner and then exploring other branches. It can also happen that instead of going in a depth-wise manner, you can go in a breadth-wise manner. What I mean to say is, let me quickly for 2, 3. What was the ABC for 2, DEF for 3? ABC for 2 and DEF for 3. So for 2, you were having 3 choices. For 2, you are having A. Let me quickly change the color. B and C. So if you store these choices in a, let's say, queue. Okay. Then after you have done with exploring 2, all the choices of the 2, you will store them in queue and then you will come to the next digit, which is 3. Now 3 is also having this number of choices. So each of these values in the queue will be having 3 choices. What will be these? Either it can be AD, it can be AE, it can be AF. So you will remove the frontmost, or say the one you have enqueued the first, enqueued first. Queue will operate in a first in first out manner. So you will enqueue, you will dequeue the first element and consider all the choices and enqueue them in the queue. It will be AD, AE, AF. Now this was level 1. This was level 1. Level 1. Okay. And the size of the digits string is 2. So only 2 levels will be considered. After 2 levels, you will be having all the combinations. So after you have enqueued them in the queue will be looking like this. Now A have been moved out, so it will be BC and AD and AE and AF. Now you will DQB and explore all the three choices and enqueue them in the queue. And in this fashion, you will be having a second level, level 2. And here you will be having all the combinations. Now, since you are exploring the choices in a breadth-wise manner, this is breadth-wise manner. Breadth-wise manner. Your time complexity will be nothing but O of breadth of decision tree, or say graph. So what is the breadth? Breadth is nothing but the number of combinations. The number of combinations at at max at a particular time, you will be having all the combinations. So the number of combinations possible will be the space that you will be required in the queue. It will be the space complexity. Now what will be the time complexity? The time complexity, for time complexity wise, it you will stop at two levels. So you need not have to worry about that also. So time complexity wise, for each of the options available, you will be exploring all the options. So it will also be breadth of the tree, breadth of decision tree. Since you will be exploring that much combinations. So I hope it's clear to you. And yeah, that's pretty much it. So now let's move to the coding part so that you will be having a clear understanding. And this is nothing but breadth first search. Let me quickly change the slide. Breadth first search. I will provide a link for article describing this also. Now let's comment this solution and move to different solution for the second approach. Yeah. So what we have done here is this is the queue that I was talking about. Queue to store the options, choice options in a first in first out manner. So this is the same number digit to letter map, and this find combinations function is being changed here. What we are doing is for all the choices of the current enqueuing, all the choices of the current digit. Firstly, you will be at the 0th digit, or say the 0th index digit in the string, digit string. So you will enqueue all the options. So then what you will do is you will consider the number of levels in queue in BFS equal to the size of the digits string. So why you are checking till the size of the digit string? Because at this point we having all the possible letter combinations in the tree. So yeah, that's pretty much it. So what you are doing is exploring all the choices, all the combinations inside queue at a particular level one by one. As you have been done with the number of combinations inside a queue at a particular level, you will increase the level. Here combination size is the level. This is representing level of BFS. So, and what you will be doing, you will be moving to the next digit, moving to the next digit in the digits string. So, yeah, at last you will be having all the combinations in the queue. At last, add all the combinations stored in the queue to the final result. And that result. And so this wraps up the solution. Also, I would like to add a little correction to the time complexities of these two approaches, the breadth first search and depth first search. Now in breadth first search, the time complexity will be the number of levels and the multiply by the number of nodes or number of values in each level, say width of level into 4. Since for each element in a level or each element in a queue, there will be at max 4 letter associated with that digit. So I hope it's clear to you. You can also see in the code also. Yeah. So the levels will be combination size. This is one loop, and there is nesting of two loops here. This is nothing but the width of current level, and this is the number of options current digit is having. Current digit is having number of options for current digit. So the time complexity will be for BFS will be this. And for DFS, you will be having at max 4 letters associated to a digit. So for n digits, you will be having 4 raised to power n time complexity. So this will be the time complexity of DFS. So rest space complexity is correct. It will not be changing. So these were the two corrections that I will like to introduce. Thank you for watching. If you have any doubts in these explanations, please reach out to me in the comment section, and I will be more than happy to clear your doubts. Thank you.